Hello, Mr. Barrett. So the question I have received is number 20. So number 20 is negative 3 over x squared minus 1. So then what I did was simplify negative 3 over x squared minus 1 into negative 3 over x plus 1 times x minus 1. So then what I noticed was the degrees are larger on the bottom, and the top numerator doesn't even carry an x. So therefore it will be considered as a bobo, giving me the horizontal asymptote of 0. So then what I did was plug in zeros for the x, giving me negative 3 over negative 1, which turns out to be positive 3, and that would be my y-intercept. To find the vertical asymptote, I then plugged in numbers into the x's to cancel out the positive one and the negative one. So the numbers I found for the x was negative 1 and positive 1. So these three items, the vertical asymptotes, the horizontal asymptote, and the y-intercept, was all graphed accordingly. So then what I did was I moved on to noticing that there cannot be a slant asymptote for its bobo, and there cannot be a hole because there's nothing in the numerator that would cancel with the denominator. So then what I did was also notice that there cannot be a x-intercept within the numerator, for there is no x. Moving on to the line graph, I then utilize negative 1 and positive 1 as points of reference. So initially, I used negative 1.5, which once I plugged into the equation gave me negative over positive, which equals as a negative integer on the graph. So then I plotted that accordingly, coming closer towards the horizontal asymptote, coming closer to the vertical asymptote. So then what I did was use negative 0.5, which once plugged into the equation came out to be positive. So once I graphed that, I graphed it as a positive integer going towards the vertical asymptote. So then after 0, I'd also have to find the end behavior of that point, or that area of domain. So then I used 0.5, which once I plugged into the equation gave me negative over negative, which came out to be a positive graph. So then I plugged it in going towards the vertical asymptote as a positive, as all positive numbers. So then what I utilized finally after the vertical asymptote being 1, so I had to use 1.5. So then I noticed that it came out to be negative over positive, which would then return simplified to negative. So then I plotted that accordingly, coming closer towards the vertical asymptote, and then reaching close to the horizontal asymptote, but never crossing because there is no x-intercepts. So then finally, I could finally claim my domain. So the domain would be all negative x values. So it would be negative infinity to negative 1 being the vertical asymptote. Then it would be negative 1 to positive 1 due to the vertical asymptote. Then it would be 1 to infinity as the domain of x, that where it can go. So this is my project, and thank you, Mr. Barrett. Have a good day.